How you going, guys? Curtis from Cutting Edge Engineering. Today's job, we have a D11T blade lift barrel in for repair. So this is going to need rebarreling. It has had repairs done to it before and it is oversized, and there is also a score running the length of the barrel. And you may also notice that the trunnion is broken, so we're going to be making a new one, and that's what we're going to show you today. So the trunnion pins breaking is a very common failure, and what leads to that is the bushes that are on the pins, they do wear out, and then the trunnion starts to hammer inside the yoke caps, and that's what leads to a failure. We do a lot of pin repairs on these where we weld them up and machine them back to size. This one wasn't caught in time, and this is the result. So if this barrel was in good condition, we would definitely do a repair on the trunnion and just replace the pin. But we are going to be making a new trunnion and not going to be repairing this because there are a few issues with it. This has already been repaired at least twice before. It is not a genuine part. Genuine parts are cast, they are not cut from a piece of plate. And I'm not exactly sure how this was built or assembled, so rather than run the risk of using an old part on a brand new barrel, we're going to make a new one. And the only things we're going to be keeping off the old barrel is the head flange and the barrel end. But before I get on to setting the barrel up in the lathe to retrieve those parts, we're going to get on to making the new trunnion. So the material we're going to be starting with, it is a flame cut profile. It is 160mm thick and it is made from 350 grade plate. So we're going to be doing all the machining in the lathe, but before I can set it up, I need to give it a quick grind up and drill in some center points. So now we've got our center holes drilled, I can set it up in the lathe. I'm going to be using my 4-jaw chuck with a centering plug and a heavy duty live center in the tailstock to hold everything in position. So the first thing I'm going to do is machine down each end, and they will become the spigots or the pins for the bearings. So I'm going to be using a standard W&MG insert to cut this material. We're going to be taking it really easy on the first couple of cuts until we get it down to a more manageable diameter, because it is a heavy interrupted cut and it is a flame cut edge. So I'm going to do a 3mm depth of cut at 145 RPM until we get through that interrupted cut. So the lathe can definitely handle these sort of jobs and this sort of cut. They are built very heavy duty. Providing we don't push the machine beyond its limits, it's going to take this without a drama. So machining this down in the lathe is definitely the fastest process. Trying to do this in a milling machine would take far too long. Flame cutting off the extra material and grinding that back, that will take quite a while, and then you're going to have to let it cool down before you're able to set it up in the machine. But there is always more than one way to get a job done. So we're through the interrupted cut. Now I'm going to speed up the RPM and remove the last 20mm of material. So we prefer to have extra material on the ends during the flame cutting process, and that just eliminates any problems if the flame cut does flare or taper, which on a bit of plate this thick is pretty common. So I've got that machine down to within 1mm of our finished size. I'm just going to flip the insert because this one is understandably worn after going through that interrupted cut, and then we can do our finishing pass. So I've got that machined to size. Next thing I'm going to do is machine down this face, and then I can machine a radius into this corner just to help prevent cracking and chamfer the end of the pin. Righto, so that end's now done. Next thing I'm going to do is flip it over and get the other end up to the same stage. So because I've reduced the diameter of this end, I can no longer use my centering plug to set it up. So I'm just going to dial it in with the 4-jaw. So I have got that running to within 0.01 of a mil. Because of the extension I'm using on the dial indicator, it is jumping across the surface a little bit, but that's going to be fine. So now I can machine our other end up to the same stage. So that's our other side machined. Now we're going to set it up so we can bore out the ID.
You just want to play.
So because the bore has been flame cut, there is no true surface to indicate from. So I'm going to use the tip of the insert on my boring bar to help dial this in. And I'm going to use my ruler to take measurements from each side so I can average that out and get it as close to center as possible. So we do have a bit of room for tolerance on these because the trunnions float inside the caps that mount to the yokes. We've got a couple of mil there, so if we're a mil out, it's not going to be a big problem. So I have taken 2 cuts, but I am having issues with swarf getting stuck behind the insert and the boring bar and leaving a terrible surface finish. I do try to avoid using coolant on these because the machine just throws it everywhere, but I am going to have to run some flood coolant just to get that swarf to clear, and that will also help improve the surface finish. So the coolant has made a big mess all over the floor, but it's definitely improved that surface finish. So I'm going to keep machining with the coolant on, and I've got 14 mil to remove to bring this to its finished size. Now that we've got the ID board to size, I'm just going to chamfer this inside edge and then face this one side. That way I've got a nice clean area to reference and measure from when we install this on our new barrel. Righto guys, so that's our trunnion machined, ready to go on our new barrel. We're going to get this out of the lathe, get the old barrel set up and get it apart, and we'll bring you back when we're fitting this to our new barrel. So I've got our new barrel machined up, we've got our head flange fitted and the other end machined down for our new trunnion. So now we can get that fitted, make sure it's in alignment and tack it in place. I'm also going to tack on the head flange, then we can get this out and weld it up. So to weld this on, I'm going to be using CIG vertical in a 1.2, that is a dual shield wire, and I'll be backing that up with Argo Shield Heavy, which is 80% argon, 20% CO2. I'm going to run that at about 26 volts and 6 meters of wire a minute. And it's going to take about 6 to 7 passes of weld around each side of the trunnion. So that's our trunnion fully welded onto the new barrel. I've also welded on all the standoffs and the head flange. What are you doing?
Oh! What's up there? Wood.
So now with all that welded, we can take it back over to the lathe and continue with our rebarrel. Righto guys, so as you can see our rebarrel is completed. The other things I had to do to finish it off was I need to set it back up in the lathe, face off the head flange because that does distort when it's welded. After I did that, I put it in the honing machine. I then honed that to spec before fitting and welding on the barrel end. So I didn't have to do any extra honing after I'd welded on the barrel end because the piston does stop just short of the weld area where it would be affected. So this is definitely an improvement from what arrived. I'm really happy with how the trunnion came out, and overall the barrel looks really good. So there definitely is a lot of work involved in a job like this, especially when you're making a new trunnion. But because you can't buy the trunnion as a spare part, you would have to buy a whole new barrel. And considering the cost of one of those, we've definitely saved our customer a lot of money. This entire repair was less than half the cost of a brand new barrel. So I hope you enjoyed this video. Thanks for watching. So we're going to be doing all the machining in the lathe, but before we start that, we need to get it prepped. So you might also notice that the trunnion is broken, and we're going to be... What?
Broken.
Oh, right. And you also...
Oh.
It started. And you also might notice that the trunnion is broken, and... So you may... So you may have all... I'm stuck, I'm on one loop. Words. That is not a genuine
That is not nice.
Yuck.
Bananas.
So I have taken 2 cuts, but I haven't... So I have taken 2 cuts, but I haven't... Go. So I have taken 2 cuts, but I...
Oh my god, man, you're stuck in a loop.
Right. So the coolant has made a...
What? What are you doing?
What was that?
What was what?
Light dropped out. I thought my phone went off.
Righto guys, so that's our trunnion machined, ready to go on our new barrel. He's behind there.
Where is he?
He's behind, he's on the Zaya. George.
So I hope you enjoyed this video. Oh, what was after that?
Thanks for watching.
Alright. But you can't buy the trunnion as a spare part from the OEM, which means you would have to buy a brand new barrel from the OEM. I said OEM a lot.
Yeah.
But because you can't buy the punion, fuck me. But you can't buy a you can't buy the trunnion as a spare part. Oh, right. How'd you start it? Come on, just say it. Just spit it out. You're making this take so long. You're gonna stab me?